By now we've covered the basics of Rust coding, at least the basics you need to know to get started with Rust smart contracts. It's time to talk about the Rust toolchain and coding practices a little more. The first topic I want to talk about is unit tests. And unit tests are easy in Rust. Writing tests that test each piece of code, they're like a default concept in Rust. Unlike a lot of JavaScript frameworks you've probably worked with, where you have to figure out which test framework you're going to use and so on. Rust unit tests are a part of core Rust experience. And so if you create that counter smart contract that CosmWasm starts with, it comes with unit tests attached. And it's generally best to write unit tests for every bit of your code to ensure it works as intended. I say generally best. Sometimes you can't do it without an integration test, but all of your code should have unit test coverage. In fact, there are tools that will canvas your entire code and figure out which parts of it aren't covered by unit tests for you. And that way, whenever you make changes, you can be sure when you run cargo test that all the pieces of your code still work as intended. You should write tests for every correct function and every correct action correctly called, and also every incorrect action. Now, we can't necessarily go way out of bounds here. If you have a function that takes a string, you can't try it with every possible string, but you can try it with all of the various kinds of strings that you would encounter and make sure that it behaves appropriately. You can even get into fuzzing and things like that, which we'll cover in later sections. But every clearly incorrect action, such as sending funds when you have 0 funds, or sending funds to an unauthorized address, or sending funds without the requester, the actor, being authorized to send those funds. All of these potential unauthorized or error states should also be tested. And I'm glad that unit tests are such a core part of Rust and smart contract development because they encourage clean coding. They encourage a modular design with small functions that do one thing. And let's talk about that really quickly. When coding, you should write small functions that do one thing. Some people don't tend to do this. Some people might fight this a little bit, but I think it's pretty clear that the most maintainable, most testable, most reliable code has small functions that do one thing that can be encapsulated in their title. You shouldn't have a function that does 10 things. What are you going to name it? Process something? Run? It's just not a good programming method to take a function and have a long function. Every function should ideally just have a few lines of code. Now, practically, that doesn't always work out, of course. But your ideal functions are short. They do one thing. They return the result. And that's not just for reusability and readability, it's for testability. If you have a function that says it adds the 2 numbers, it's very easy to test that it correctly does that and keep that test active no matter what you change elsewhere in your code. Here's a really simple example. Let's say you had that rock, paper, scissors game and you just put everything in a process move function that took the 2 player inputs and did everything to them. It compared them, it came up with a result, it adjusted the score, it checked for an end game and so on. You can still do that in the process move function, but all of those bite-sized steps should be broken out so that you have a function that compares elements, and all it does is compare elements. It returns player 1 wins, player 2 wins, or a tie. And then you have a function that updates the score of the match if you're maintaining that over multiple rounds. And then you have a function that checks whether the threshold has been reached. Best out of 5, that means 3 wins. So checks the end of the match. You shouldn't do all this in the process move function. It becomes more complex to test. And if you make changes, then you'll have to change the tests. But if you make changes in process move and it doesn't affect these other steps, then all those other tests will still be fine. And you can be sure that you haven't changed that functionality accidentally as you updated your main function. Another example, and I'm just making some of the terms up here. This isn't exactly how you do this, but it's an example of some architecture where you're unstaking and distributing funds. Learn is brought to you completely free because of our great sponsors. Neutron, enabling developers to build breakthrough applications and onboard users from anywhere. Osmosis, the premier decentralized crypto exchange. And Obi, the smart new standard for asset management. If you want to become a smart contract developer through this lesson and others like it, head to heretolearn.xyz for uninterrupted course videos, coding exercises, and feedback directly from experts in the industry. Let's say that a user and a token, this function is called with a user and a token, unstake and distribute funds. Well, first we should assert that the user is authorized to do this through whatever means we have at our disposal, and then get the staking pool, is the associated staking pool with that token. And then I'm assuming the pool has an unstake function. We get some funds object that's pool.unstake. And then we distribute funds using the user's distribution rules. And then we maybe emit an event, we notify recipients, right? All these sub tasks, and there might even be subtasks under here, should be handled by their own little functions. And then the main function, this unstake and distribute funds, calls them in turn. And now you have these unit tests for all these little tiny functions instead. And it's much easier to keep your testing accurate, up to date, easy to read, comprehensive, and so on. Here's a tests example where I have a module tests, and it tests, you declare them in their own module. This attribute config test, it means that this code is only compiled when you're in test mode, when you're running cargo test. It's just ignored if you're building for production, for instance. And you can use this attribute throughout your code. So let's say, for example, that you had a dummy setup player or some dummy setup function that only is for tests because you don't want to actually deal with user management or something for your tests. Then you can put this config test attribute above lines in your actual code that need to be affected, and they will only be compiled when you're in test mode. So if you have like some things in your code that should act differently in test mode or not test mode, you can use this test attribute or not test to declare, this should only be true when it's not test, this should be true when it's test. In this case, this whole module is only compiled when we're in test mode. And it's very common to see use super and everything from super. So you're using all the things from the file, from this particular file these tests are in, you're pulling in all the functions. I personally like to separate my tests out into their own file. You can do that or not, it's up to you. But it's often seen that unit tests go at the bottom of the file that includes the functions and structs that they're testing. Then you might have some testing libraries. It doesn't apply really to this, but the CosmWasm standard testing, for example, imports some testing functions you need to kind of pretend there's a network and pretend there's an API that does authorization and depths and environment and so on. And you import that and you'll use that throughout your tests. And here you declare your tests as functions with a test attribute above them. Not all your functions need to have tester attributes. Maybe you break out little functions here as well, helper functions. Just like we did back here, your tests can also have helper functions so that they can share code among themselves, be more readable and modular. You don't have to put test over those. In fact, don't. Put test over the things that you want to test, the individual tasks which should pass or fail. Within these blocks, you'll run the code, and if it doesn't panic, your test will pass. That means you want to unwrap explicitly. We talked in unwrapping about not using unwrap in production. Use unwrap or else, unwrap or, okay, or whatever, match. But in these test blocks, you definitely want to use unwrap. And if you expect an error, you'll use unwrap error. In the unwraps case, you throw a panic if it's an error. You unwrap it. And if it's an error, panic, test fail. In unwrap error case, you expect it to be an error. Very useful for, let's say you are doing an unauthorized action and you get the result and you expect it to be an error because it's unauthorized. If it's an error, the test passes. So in that case, you unwrap error. And if it's okay, the test will fail. You can also assert and then any kind of function that will resolve to true or false in there. And if whatever's inside is false, throws an error. And you can assert equal. These are macros. And just put in the two values in the parentheses here, x comma y, for example, left comma right. And if they're equal, you're fine. If they're not equal, then you'll throw. There are other methods as well that you'll see, but these are the main ones. You put these in your tests somewhere, and that way you're defining what will result in the test failing or passing. And you may have these all over the place. You may instantiate your contract and then unwrap create a new player, and then unwrap, create a new move, and then unwrap, check the game, score, and unwrap, and you may have multiple unwraps in the same test. That's fine. If any of them fail, the test will fail. Remember that you should write tests for every single action, every correct action and every incorrect action. And I actually don't particularly love this setup here, where it's kind of game-wide tests. That is appropriate for a place. That does have its place. But you should have each function tested. The compare function, for example, where you're comparing elements, a test that compares different elements makes sure the winner comes out on top, and one that compares tied elements, maybe additional ones. Maybe you use random elements every time with some kind of determining chart, and that way the test is prone to fail eventually, probably, if there's some pair that has a problem with it. Maybe you literally run through all pairs programmatically in your test and compare all the elements, as much as comprehensive as you can make it. And then this check end match function as well, where I'm just taking as another example that end match function that checks whether the match is over or not. It should not only check that if the match is incomplete, it continues, but it should check that if the match is over, it ends the match. So you should check all your cases where you expect the function to return true or false. Check where you expect your functions to throw errors and handling them correctly, where you expect maybe there to be bad inputs. Check all the actions you can generally think of, all the actions within reason that could happen here, and write unit tests for them so that you're sure that as you code, as you continue developing your program, you don't break basic building blocks that will really throw you off and maybe be hard to debug as you're working at some higher level. You can read a lot about unit tests in the interactive Rust book and Rust by example, and take a little quick quiz on it over at heretolearn.xyz/unit tests. And you can also access the testing 1, 2, 3 exercise, write your own unit tests for the code provided, make sure that you write unit tests that cover the cases mentioned, and when all your tests pass, you'll be done with exercises and ready to proceed to the next video on your journey to becoming a Rust smart contract engineer.